Hello, hello everyone. Welcome to Karmada community meeting. Today is April 29th. Okay, let's get started. Today we are going to talk about the federated resource quota proposal. As I said on the PR that we talk a, a lot about this feature locally. So before Zhang started, any update from your side, Mihashi?
No major updates from my end. I briefly took a look at the design doc that was linked. So I was hoping we could kind of go over that together.
Okay. John?
Oh, yeah.
Yeah.
Can you hear me?
Are you going to share? Yeah. Are you going to share your screen?
Okay. Oh, hello. Can you see my screen?
Yeah. Yes.
Oh, hello everyone. This is my design of federated resource quota. First is how to calculate the quota usage. Federated resource quota predicts the resource usage of member clusters through the control plane's resources. Therefore, the resources used for calculating quota usage need to be able to simulate the resource state of member clusters as closely as possible. This is the resource model of Karmada. You can see the process of resources being deployed being plotted by users and then propagated to member clusters can be divided into three steps. First is resource template, then resource banding and work. Ultimately, we choose RB to calculate the resource usage of member clusters because resource banding contains complete cluster distribution information, which can be used to calculate the total replicas and contains the resource request info. For example, this is a manifest of resource banding. We can see the usage of this RB is 1 plus 1 and then multiply 50 equals to 100. While we both use resource banding to calculate quota usage, this zero may be some difference in my calculation approach. My approach includes spec clusters in the calculation in order to account for scenarios involving replicas duplicated across clusters. Uh, then is the admission controls. To achieve the purpose of limiting the total resource usage within a namespace, it's also necessary to intercept resource create or update requests. In KBS, the ability to intercept resource create or update resource requests for resource quota is implemented through built-in admission control. Federated resource quota can achieve the same effect by using a validation webhook. The specifics are as follows. First, we can first watch the create or update events of resource banding, and then filter events with spec clusters or spec replicas requirements changed, and then do the quota usage validation. When Karmada scheduler generates a new scheduling results and attempts to update resource banding spec clusters, if the new scheduling results would exceed the quota limit, the webhook will deny this update request. as well as it will update quota status overall used first and then approve this update request. When the detector updates the resource binding spec replica requirements, if the new resource binding spec replica requirements would exceed the quota limit, the webhook will deny this update request, as well as it will update quota status overall used first and then approve this update request. I decided to intercept resource binding update events rather than resource template create or update events for a few reasons. First, resource template only contains request info, not how the resources are distributed across clusters. Since quota usage is calculated based on resource binding, intercepting resource template correction might lead to tie-in issues that make quota enforcement unreliable. And the last one is intercept resource template correction events may be more useful friendly in terms of visibility, but is too broad and hard to manage consistently. This part is how we should to handle concrete requests when the webhook approves the resource create or update request.
Sorry, John. Can you
Mm-hmm.
wait a minute? Any
Yeah.
questions so far?
Yeah, I had a few. So, just so I understand, we had originally implemented this internally using a validating webhook that just monitors the resource itself. I thought that on the proposal we had a discussion about like what the drawbacks of this approach are, specifically in terms of bulk applying or updating resources. Like that's not going to be reliable enough. So just so I understand clearly, this is an admission controller that will be monitoring resources that we're applying, or is it only going to be monitoring the creation and update of the resource binding object? So for example, is it possible for users to apply their resource and then only at the resource binding level will Karmada enforce the resource?
Yeah, I think the difference between the approach we talked at the last meeting is yeah, exactly as you mentioned. We can only monitoring the resource binding. So I think it's a little bit easier for us to manage the webhook. For example, it's not need to monitoring no need to monitor all kind of resource types, and it doesn't need to use the resource interpreter to get the resource usage. So yeah, basically that's the idea.
Okay, that makes sense. From the perspective of like the user when they're applying a resource, because I'm thinking about how like the resource quota admission controller works in Kubernetes. Like if you bulk apply a lot of resources, you'll notice like it starts to print, okay, this resource has been applied, this resource has been applied. And then eventually one of the resources that goes above the quota will say creation of this resource failed. You've gone above your limits. So is the same sort of behavior going to exist in Karmada, or will all the resources just get applied and then it's up to the user to determine why their resource binding didn't get scheduled? Like, is that like, are we essentially enforcing the quota usage on the scheduler side, or are we actually enforcing it using this admission
Yeah, so
controller?
I'm trying to understand. So like, Middle License wants to produce a new data set.
Yeah, yeah. This idea don't will not deny resource create update. It just works at the resource binding level. Uh, so if a resource update exceeds the quota,
Yeah. They have some pipeline basically. Yeah.
who is talking?
Oh, I'll mute myself, sorry.
Okay. So if a resource is exceeds the quota, and the scheduler makes a decision, and the resource quota controller will stop the propagation process, and then maybe the controller could send some events to the resource, or
Yeah.
Okay, so the way I'm picturing it based on my understanding is, let's say a user applies like 20 different resources. The
mhm,
federated resource quota only has like space for 10 of those, right? So 10 resources will get 10 resource bindings for those resources will get created because those are within
mhm,
the quota limits. As soon as the 11th resource binding attempts to get created, our validation admission controller will say, you're going above the limits. We're not going to create this resource binding. Or are we just going to say, okay, resource binding can get created, but we're not going to schedule it? I guess that's where I'm getting a little bit confused.
yeah. Um, Actually, we don't stop. We don't stop the resource binding creating. The resource quota controller works after the scheduler. So you can see, let's say that even even though the scheduler make a decision, and for example, the scheduler tries to schedule a workload to my cluster one, and then and the result quota controller checks the quota and say no, it's not allowed because it exceeds the quota. So the result quota controller can stop the following process, and
Okay. Okay, sorry, I missed this. So, okay, that makes sense. And then I guess we would update the status of the resource binding to indicate that the update request failed because we exceeded the quota limit.
yeah. The behavior is similar uh, to Kubernetes, like you deploy deployments to Kubernetes, and the even the even the deployment will exceed the quota, but Kubernetes don't deny the creation of deployments, and and yeah, and if the deployment exceeds the quota, you can explore the status of deployment to know, or the reason why post a pod not be created because the quota limits.
Okay. Understood.
In that case, so Mihas, if I understand correctly, in that case, like resource binding will stay there, and until it's not gonna get the resource, it will gonna go and retry, right? It's doing kind of like trying to reconcile that, correct?
Would we have some sort of retry mechanism, or would we just keep the validation? Like, would that just happen once, and then until the federated resource quota usage changes, then we would decide to attempt to reschedule?
Because the idea is that like
maybe I can share.
if we don't try to reconcile or re-update, then like what are the resources created, right? Do we have a mechanism to clean up those resources? Because we don't want to fill up kind of etcd resources or anything like that, right? Let's say you create that object, it marks status as a fail, and how the cleanup will perform and everything.
There's no cleanup that gets performed. It's just that the resource itself won't get scheduled to a member cluster. So, like it's up to the user at the end of the day to make sure that they're not exceeding their quota limits. If they do exceed it, then Karmada will at least like save the resource itself in etcd, but the resource binding itself will have this quota exceeded error and prevent the scheduling from proceeding. So I don't think like it's gonna swamp etcd with too many different resources. I mean, I don't know, Honkai, what your opinions are. But I think it shouldn't be a major concern.
So I'm like very new. I'm attending this like very first time. So just want to say, so when like resource binding object created, right? That is like literally object and store in the etcd for like store in etcd, right? Basically.
Yeah.
So yeah, I mean like we had like past, I don't want to diverge, but we can talk offline. But we had like issue with like such objects get stored in the etcd and like not cleaning up in a time, and then etcd is kind of like slowing down and whole cluster becomes like a non-accessible. So that's the reason like I asked that.
I see. And you've never had to also.
Do you know what order of magnitude you're talking about, like in terms of like the amount of resources that we're filling up etcd?
So this was like a Spark CRD object, and etcd size was like 3 to 4 gigs. And we have around like 30,000 objects, and then like etcd started to give up, slow down, and then like eventually it becomes cluster becomes like non-functional.
Okay.
Yeah. I don't want to diverge, but yeah, we can like.
Okay, fair enough. Yeah, we would just need to be cognizant of how much space we have in etcd and make sure we don't exceed that quota. But
okay,
I don't think that should be a major concern.
So it's a common thing.
Anyway, perhaps we can talk about it more as soon as we're finished going over this. Okay. Yeah, if we want to continue going through, I'll listen.
Yeah. Okay, I will go through it. This one is how to handle concurrent requests. When the webhook approves a resource create or update request, it will first update quota status overused. And when there are multiple concurrent resource requests, if these requests perform quota usage validation based on the same resource version of the resource quota and pass the validation, the only one request to update the quota status overused can succeed. Other failed requests will will validate the quota usage based on the latest federated resource quota after failure. Sorry for the incorrect information provided earlier. The mention of the resource quota in KPS using namespace queue was more related to performance optimization rather than being the actual reason that ensures quota limits are not exceeded in bulk request scenarios. This one, any question? I will hopefully see this picture. This picture is the overall process of federated resource quota. It can be divided into two parts. First one is quota usage calculator. When quota change or delete resource banding or periodically, it will the Karmada control manager will get all resource bandings in the scene space of the quota and filter workloads. Use resource banding spec clusters, multiply spec replicas requirements to get the resource usage and update the quota status overused. The next part is the validation webhook to enforce the quota limit. When the webhook receives a create event or update event of resource banding, it will get all quotas in the same space of the resource banding, and then calculate the delta usage. If the delta usage plus the status overused exceed the quota, it will deny the request, deny the update or the create request. Otherwise, it will update the federated resource quotas status overused first, and then approve the request.
Okay, so this flow makes sense, but I have a few questions. So
Yeah.
on the Karmada controller manager side, so we already have an internal implementation of this feature that we use. So our controller for the federated resource quota usage, we also just fetch all of the resource bindings. But I thought that there was some concern with regards to performance there, right? Because if each time the controller is reconciling and it fetches all resource bindings, like that might be quite a lot, right? Computationally. So was there any sort of decision as to how to optimize that? Like we had been talking about maybe containing some sort of internal cache. So at least we could like fetch the resource bindings a bit more quickly, but I don't know if there were any opinions on this. Because yeah, we can just fetch all of the resource bindings in the same namespace. That's fine. But
source of data as well. They might just be sources for a lot of
yeah, I think this part of how to calculate the quota, the idea of a calculate the quota, the idea is based on your proposal. I think there's no difference. So for your question for the performance, I think we haven't go so far yet.
okay, yeah, I was just curious if there was any conversations there. But if not, that's okay. We can also just iterate after like the first implementation's finished. And then secondly, so I guess this is building off of the question that Bomek asked.
real-time pricing product.
The existing behavior for the Karmada scheduler is if it fails to apply a specific work to a cluster, it'll attempt to retry to create or update that resource with exponential backoff, right? So is the same sort of behavior going to happen with regards to the quota? So like if a resource is attempting to get scheduled and it updates or tries to update the resource binding to set the cluster that it's going to get scheduled to, and we keep denying it because of the quota, like will the scheduler keep trying to retry, or like
Yeah. That's a good question. Yeah, actually, we also that's definitely that's a concern for if the scheduler tries to make an update on resource binding, but the update operation is always denied by the by admission control. So we are an idea to solve this is once a resource binding is denied by resource quota controller, the controller can set an status or conditions on resource binding, so so that the scheduler will get the status. The scheduler will get the info that the resource binding is denied by resource quota controller. So I think that the scheduler can break the loop.
Yeah, just when the update event of the resource binding was denied by the validation webhook, it will return a unschedulable error. For the 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 Karmada scheduler will not to reconcile the unschedulable error resource binding.
So I'm asking that question because in our use case, right, we have like a two components. In a Spark, we have driver and executor, and users specify like executor number higher. Now at given point of time when it's scheduled, we won't have enough resource available in a cluster to bring all the executors up and running. But knowing the fact whenever the resources are available, we want to make sure those executors will go up. And if we are like sending out like unschedulable error, and if that is not happening, that means that like despite our member cluster has a space quota after let's say 30 minutes, still users is not able to like utilize their full capacity. Because then the idea is that like, oh, now does our controller need to go and check that like, oh, resources available and try to reschedule those set of executors, or Karmada, this controller, quota controller will make sure that like, it can handles either by specifying number of retries or until it's not schedulable or like workload get deleted, that kind of thing. So it can have like a, we can think of as like a multiple condition under which condition we want to do a retry, non-retry, or if we want to do the retry for like infinite time, or we want to do retry for certain number of time and then give up kind of a thing. Yeah.
Bhumik, in your case, are you saying like, okay, a user has applied a bunch of resources, those resources eventually get deleted, you're saying? And so it frees up some space on the member clusters.
Mhm.
And then how do we cause like a application to be able to get scheduled again because the federated resource quota has released some space?
Yeah, so we don't have kind of like the standard kind of like a long running service. We have a use case where, like workload comes, it performs like a computation and go away, right? So in our use case, like most of the applications are like some application run for 10 minutes, some runs for like 3 hours. And I mean, like a user's understanding is they want to run with the full capacity, but Spark allows to run with the reduced capacity if the resource are not there. And as soon as the resource available, it can scale back up to the full capacity and try to run the workload. So in our case, yes, for given application, it can runs with the partial capacity, but yes, it is better that like if resource is there, then like we can go ahead with the full capacity. And cluster state will fluctuate a lot based on the number of workloads comes and go.
Yeah, I'm wondering if there's some way to refresh the resource binding and remove the unschedulable errors so that I can kind of try
you
to
mean
reconcile again.
you mean if the quota usage can meet the update event of the resource binding, how to re-queue the unschedulable resource binding?
Exactly.
Oh,
Yeah.
oh yeah. The first the unschedulable error it stop the request of this update event. So if you edit the resource binding, it will re-queue the scheduler queue again. And then if the quota uh has changed, I think we need to refresh. We need to identify the the resource binding which are denied before to requeue the scheduler queue. I think this can solve your question.
Yeah, I think so. I guess who would be responsible for requeuing the resource bindings though?
My opinion is to use scheduler because we can see wait a minute.
Sorry, I think it's the resource quota controller's responsibility to to reconcile the resource binding, which was denied before. For example, once a resource binding is denied by resource quota controller, the resource binding will be something like put the resource binding to a waiting list, and once there's a change on resource quota or other resource bindings, we can try to fetch the resource binding in the waiting list and to see if there's a chance for this resource binding to reconcile again.
Yeah, I think that sounds good.
That makes sense too. Okay. Here is the demo. Take a take class failover as example. Use a federated resource quota with 40 core CPU and 40 GB memory. Before failover. Below we can see for Flink deployments. Uh, they are subdivided into two clusters. Flink A and Flink B was in member E cluster. Flink C and Flink D was in member 2. Then member E failed. Flink A and Flink B need to migrate to member 2. We can see the change of the resource binding. Only the cluster was changed. Since the replica and the resource request have no change, the delta usage caused by the resource binding update is 0. It will pass the quota verification. Eventually, Flink deployment A and Flink deployment B will be successfully migrated to member 2.
I see.
Yeah. I also prepare a demo in my old development machine. We can see 0 is a rated resource quota. It's overall limit CPU to 100. And 0 is no used now. And the deployment was 50. And then I will try to apply this to member E, member 2 and member 3. It will be 150. It will exit the quota. We can see 0 is a event. It shows the webhook denied the request because the CPU is not enough. Okay, and we can see the deployment. It will have the same event too. Okay, and we can see the there is low deployment in the member clusters. Then we will try to apply them to member E and member 2. It will pass. I can see, you can see it succeed. And then we can see in member E and member R, the resource have been propagated to member E and member R. And the overall used have been updated to 100. Okay. Then we try to change the member 2 to member 3. It's like the failover. We can see the pod in member 2 have been migrated to member 3.
Awesome. Yeah, this is great. Thank you.
Yeah.
I have a question. So you mentioned that like if multiple update request happens at the same time, it will only go through one of them and the other gonna fail.
Yeah.
Okay, the other one.
This
Well,
part.
okay. Yeah. So my question is the other. So those like the following request will fail for the same resource. It won't retry, right? It just fail.
Yeah.
And tell
Yeah.
tenants
will,
that. Okay.
If the request was denied by the executor the quota, it will not retry. But if the update request was failed due to the conflict, it will retry.
Okay, in that case, that's due to the conflicts, right?
Yeah.
Okay, it will retry.
对，yeah.
I see. Okay.
Yeah. If due to the conflicts, it will retry.
Okay, sounds good. No, that's my question.
I will show you my webhook communication. It add a simple dash webhook like this. It watch the create or update events of the resource binding. Yeah.
Okay.
Great. I'm curious because I know that the next Karmada release is going to be at the end of the month on May. Like, do we have enough time to merge everything in?
Good question.
Yeah. So I think sorry, can you hear me? I just dropped.
Yeah.
Yeah, we have about less than a month for this feature, but I really hope we can have at least a MVP version for this feature. So I'm thinking how to move this feature faster. So I propose currently the proposal from sent by Mihashi. I think we have a very clear scope and motivation. So we have a so next we need to add some detailed design to the proposal, and I think we can make a final decision as next week, and so that I think we probably can have a MVP version in the next release.
Okay, sounds good. I'll update the proposal today, and I can reflect some of the design decisions that we've agreed upon. With regards to implementation, should we create a separate issue just tracking the different parts of the implementation? Because Lee and I can also help out. We have some open work.
Okay, sounds good. So sure. Are you today? I think today Drone just provide another approach for how to handle the webhook part. For the controller part is I think there's no difference with your proposal. So do you need a Drone to add the content to the proposal, or
I can add the content to the proposal, and I can we can have the authors be co-authors on the proposal, since part of it is from his design doc as well.
okay.
But yeah, I can update it.
Okay, so I can help to open an umbrella issue and try to work out some iteration tasks. So we can I mean I can help to open an issue for for listing the tasks for this feature, and you and Li Wang and Zhuang also can work together to try to deliver this feature in this release.
Yeah, sounds good. I mean, I can update the proposal in like 30 minutes. So, yeah, we can get started on working on it as soon as possible.
Yeah, that sounds great. Okay.
Yeah, I have a quick question. So I saw the failover cluster failover feature will be a feature gate eventually.
Yeah.
Let's say if a tenant, if a user turn off the cluster failover, does that impact the behavior of this federated resource quota?
No, I think the failover feature is quite different from the resource quota feature.
Okay, so the calculation will still be the same for the quota, will still be the same.
Yeah.
Okay. Okay.
So speaking of the failover feature, I see you noticed the proposal. I think the idea is that we are trying to refactor. Actually, we are refactor the failover cluster failover feature, and we also want to bring the feature that we did last year for the stateful side application status injection feature, and we want to bring that feature to cluster failover feature 2. So we'll let you know. I think I will see you once the proposal work out.
Yeah, that sounds good. I will keep watch for the proposal.
Okay. So since no more topics, so see you next time.
Yeah, see you guys.
So
Thank you.
Take care.
Take care. Bye.